Welcome to Chapter 12. 12.1 is information needed to perform a dosage calculation. So the purpose of a dosage calculation is determining the amount of drug to give a patient or the amount to administer. And the dosage calculation process includes these following 3 steps. So the first step is gathering information. All right. So when you're gathering information, the first thing you need to know is the dosage that was ordered. Okay, so how much of the medication the patient is to receive. And then the dosage unit. Okay, this is the form of medication that is available to you, such as tablets or capsules. You can get this information from the drug label. Then you need to check, what do you have on hand? Okay. And then after that, what is the desired dosage? Is it stated in the same unit of measurement as the dose on hand? So that's the question. And then after that, what you're going to do is convert to the dosage desired or ordered. So if your dosage ordered is already in the same units as the dose on hand, then the dosage ordered is the same as the desired dose. If not, however, you will need to convert the dosage ordered to the same units of measurement as the dose on hand before you continue with the dosage calculations. So sometimes you may not have the same units as on the order label, so you'll have to spend some time converting before you can actually find the right dosage. Now let's take a look at the language of dosage calculations. All right, and this is on page 253 of your textbook. So for dosage ordered, the abbreviation for that is going to be a capital O. And this is the amount of drug to be given to the patient and how often it is to be given. Okay, so you obtain that value from the order of prescription. And an example of this would be 20 milligrams daily. So that would be the dosage. After that, we have the dosage unit, which is a capital Q. Remember, this is where capitals and lowercase start to become important. So the quality of solid or liquid in which the dose is supplied. Obtain this value from the drug label as well. And an example here would be capsules. Then we have the dose on hand, which is a capital H. The amount of drug contained in each dosage unit. Obtain this value from the drug label as well. So for example, we might have 10 mg. So this would be the drug label, not the prescription. All right, and the desired dose would be capital D. So the amount of drug to be given at a single time. All right, so each time you take it, this would be your capital D. An example of this would be maybe 20 mg for each dose. And then after that, we have dosage strength of the supply dose, which is H divided by Q. So it's the dose on hand per dosage unit. And we're going to again obtain this from the drug label. So it might say something like 10 milligrams per capsule. And then the amount to administer would be a capital A. So the amount of, or the volume of a liquid or the number of solid dosage units that contains the desired dose. For example, 2 capsules. Alright, so here we go with the main languages for dosage calculations. Let's move on. Alright, so for our example, the order is 500 mg. And what do we have available? Well, we have available 250 milligrams per packet, or tablet, Find the desired dose. So in this case, the unit for the dose ordered is the same unit. Okay, so the units are the same. We have milligrams and milligrams. So no calculation is needed for the changing of the units. The drug measured is in milligrams on both our order. So our order is milligrams, and what we have available is milligrams. So our desired dose is going to be 500 mg. Capital D for desired dose. So for example 2, let me write into our problem what we're actually trying to find. So, for example 2, we're trying to find, or what's ordered is nitrostat, our little trademark R symbol there, 800 micrograms sublingually, PRN, chest pain. All right, so this is what is ordered, and this image here is the drug that we have on hand. So we're going to have to see what we have on hand and compare it to what has been ordered. So first, let's check our units. Are they the same? Well, the units for our desired dose, it needs to match the units found on the drug label. So what are the units found on the drug label? Well, on the drug label, we have the units milligram right here. Oh, that wasn't the best highlighting. Let's use a slightly different highlighting. We have, once again, not the best. Let's go with red. We have milligrams, and then, though, on our order, we have micrograms. So to find the desired dose, the first thing we do, we're trying to find that dose, remember? We need to convert the order into something that makes sense with what we have on hand. Okay, so we're going to convert our order amount to make sense with what we have on hand. Alright, so that means we need to convert 800 micrograms into being milligrams, and that first will show us what the desired dose is. So the first thing is we need to know the conversion factor. Okay, the conversion factor we're going to use here. We know that 1 microgram is the same as 1,000. 1 milligram is the same as 1,000 micrograms. So we're going to go ahead and use that. So let's set up a proportion to solve. Okay. So we're going to use capital D for our dosage because that's what we're trying to find, the dosage that we need. And we're looking for the dosage in terms of milligrams, not micrograms. And we'll set that equal to our conversion factor. Let's go ahead and cross multiply. You can pause the video and try solve by yourself and then check back in with me. Alright, and then we can go ahead and cancel out the like units there. And then divide by 1,000 from both sides to get the D by itself, our desired dose. And what do we have? Well, that cancels. Oops, that doesn't cancel. D equals, well, the 1 times 800 is going to be 800. 800 milligrams divided by 1,000. And simplifying this, we're going to end up with D equals 0.8 milligrams. So our desired dose is 0.8 milligrams. Okay, so just finding the desired dose at the moment. And let's take a look at example 3. Alright, so for our next problem, example 3, we have an order of 10 milligrams by mouth daily. So PO daily. And the dosage strength available is 5 milligrams per tablet. So we're trying to figure out what is the desired dose we're looking for. Okay, and remember, we're always trying to match our desired dose to what we have on hand. Well, let's check the units. We have milligrams and milligrams, so the units match up. So in this case, the unit for the dose ordered is the same as the dose that we have on hand, so we don't actually have to calculate anything. The drug is measured in milligrams on both our order and the drug label, so our desired dose is going to be the same thing as on the order. Nothing changed. Moving on. So for example 4, we're going to use dimensional analysis. to solve. So the dosage ordered is 0.2 milligrams once a day. The dosage strength available is 100 micrograms per tablet. Find the desired dose. Okay, so as usual, remember we're going to be trying to match what was ordered to what we have on hand. First things first, let's check the units. Well, the units that were ordered were milligrams, and the units that we have on hand are micrograms. So units are not the same. Let's just write this down. Units are not the same. So we need to convert. And we're trying to go, remember, we're trying to go to what we have on hand. So what we have on hand is micrograms. So we're going to convert from milligrams to what we have on hand, which is micrograms. Okay, so ordered what we have on hand. Okay, so let's go ahead and switch from 100 micrograms. So let's see our unit of conversion. Our conversion factor is going to be 1 milligram equals 1,000 micrograms, similar to what we used before. So setting this up as a dimensional analysis problem, I'm going to go ahead and first just clean this up here. So we're going to create our equation. The dosage we want is going to be equal to the quantity being converted, which is the dosage ordered, multiplied by our conversion factor. So the amount being ordered is 0.2 milligrams. And we're going to times that by our conversion factor, which is right there. And our conversion factor, we want to cancel the milligrams, so because of that, when I put out my conversion factor, I'm going to put the milligrams on the bottom so that they can cancel. Okay, and once we do this, we set it up our dimensional analysis, the units can cancel, and we're left with D equals 0.2 times 1,000 micrograms. Multiplying that out, D equals 200 micrograms. And there we go, we have our desired dose. So the desired dose is 200 micrograms, and period. All right, moving on. So that is it for 12.1. Now let's move on to 12.2. So methods of dosage calculations. So we're continuing on. Before we were just finding the dose, so now we're going to actually continue with figuring out what else to do when we are solving for our dosage calculations. So we will look at 3 methods for calculating dosages, the proportion method, dimensional analysis, and formula. So proportion and dimensional analysis we have kind of gone over before. We tend to be using proportion a lot. And we will be learning the formula method for dosage calculations. So a few steps to remember as you're calculating. First things first, gather all the information you needed and convert if you need to, which is what we practiced in 12.1. After that, you're going to calculate using one of the 3 methods. 1, 2, 3. And then after that, just pause and think. Does your answer seem reasonable? So let's go ahead and work on our first example using the proportion method. So we've had, this is our order. Okay. And per mouth daily. And we're given, our label here, metformin. All right, and this is in terms of milligrams. So what we have on hand is milligrams on hand. And we are given our dosage in terms of grams. So the first thing we need to do is turn this into the right dosage with what we have over here. Okay, so let's go ahead and do that using proportion method, which we do a lot. So what is our conversion factor? Well, we're going from grams to milligrams, so our conversion factor we're going to use is 1 gram equals 1,000 milligrams. Okay, we can go ahead and set up our proportion with D as the dosage that we're looking for. Over 2 grams, and we're trying to figure out how many milligrams. Okay, so we're going to go ahead, cross multiply. If you want to pause the video and solve this by yourself and check back in with me, go ahead. Alright, and then we go ahead, we can cancel out the grams, and then we're left with our dosage is 2,000 milligrams. Okay, so now that is the desired dose. Oops, dose, not sauce. So now what we need to do is figure out how much we're administering. Okay, so this is the next step we're learning now. So the first step is what we did in 2.1, so now we're learning the 2.2, which is the second step, and that is amount administer. So how much to administer? Minister. Alright, ooh, that was really ugly. Let me go ahead and erase that real quick. Administer. Alright, so real quick, when we're using proportion method, we're going to set it up as follows. Okay, so the dose on hand divided by dosage unit is going to equal the desired dose divided by amount to administer. Okay, and this is on page 263 of your book if you want to reference it. And another way to look at how this is set up, this is H over Q equals D over A. Okay, formula to memorize when using proportion. So let's go ahead and do that. Alright, so let's set this up. So H over Q is going to end up being 1,000 milligrams all over 1 tablet. Alright, because the dosage unit is right here, 1,000 mg in each tablet. And that's going to equal, so setting up our proportion, the desired dose is 2,000 milligrams all over, and the amount to administer is what we're searching for. Alright, so once again, H was the dose on hand, which is this value. The dosage unit was 1 tablet, which we got from over here on our chart. And then the desired dose is what we found in the first step, and the amount to administer is what we are searching for. Okay, backed up a little too far there. Alright, let's go ahead and solve for the amount we're trying to administer. Okay, so using cross multiplication, once again you can pause the video and try this on your own. Alright, and the milligrams will cancel out. So then we have A times 1,000 equals 2,000 times, well, 1 is just going to be tablet. 1 times 2,000 is just going to be 2,000. We can go ahead and divide by 1,000. (2,000) divided by 1,000 is going to be A equals 2 tablets. Alright, so there we go. That is the amount to administer. So the amount to administer is 2 tablets. Okay, so the first step we did was to find the desired dose in the units of what we had on hand. Right here, desired dose. And then after that, we went ahead to find out how much to administer. All right, let's go ahead and look at the third example. So real quick before we continue with that, please note that this is not the correct chart for our problem. We are given what we have on hand over here, which is a little different than that chart. So we've ordered this amount, which is 500 milligrams, and then we have on hand 250 milligrams. So first things first, we always check to see if what we have on hand is in the same unit. So do I need to convert? Well, if you take a look at the units, you'll notice they are both milligrams, so we do not need to convert. Awesome. Next thing we're going to do is just go ahead and solve for the amount to administer. So no need to convert. Just solve for amount to administer. Alright, and to do that, we're going to go ahead and solve using dimensional analysis. So what we want to know is the number of tablets. So A tablets, we know that in one tablet there is 250 milligrams. So one tablet, we have 250 milligrams. And we're going to multiply that by what we have there, 500 milligrams. Okay, so the reason we had it this way is because remember we're trying to cancel out with the milligrams from the bottom to the top. Alright, and when we do that, those units cancel out, and we are left with A tablets is equal to 1 tablet all over 250. And actually I'm going to cancel the zeros there as well while I'm doing this. 25 times 50. And then we can simplify the 25 and the 50. 25 can go into 50 twice. So we're going to be left with A tablets going to equal 2 tablets, which is the amount to administer. So the amount to administer is 2 tablets. Okay, so this one was nice. We didn't have to convert because they were both already in milligrams. What was ordered was in milligrams, and what we had on hand was also in milligrams. Alright, so let's take a look at example 4. Once again, we're using dimensional analysis. And we have ordered Norvir liquid, 40 milligrams by mouth daily. And then on hand, we have Norvir, but it's 8 milligrams per 1 milliliter. Alright, so let's see. First, do we need to convert? Well, let's take a look at the units. This is the units I have on hand, and these are the units that I need in the order. So since they're both milligrams, there is no need to convert. So we can move on to our second step. Alright, so the second step, the amount to administer is going to be in milliliters. So this is the dosage unit, or how the medication is supplied. So for dimensional analysis, we have how many, remember A, amount to administer, A milliliters equal to, well, there's no dosage conversion factor needed, and our dosage unit is 1 milliliter per 8 milligrams. We get that from over there. And our dosage ordered is 40 milligrams. So we'll go ahead and multiply this by the dosage ordered. You can put that over 1. Once again, we can cancel out the units. And simplifying, let's see, we have A. So the amount to administer, remember, is A milliliters, 1 milliliter over 8 times 40 over 1. Multiplying that out, we'll get AML equals 40 divided by 8 milliliters, which is going to be A equals 0.5 milliliters, which is our amount to administer. So the amount to administer is 0.5 milliliters. All right, let's keep going. So that was dimensional analysis. Now we're moving on to the formula method, which is the newer method. So for the formula method, we're going to use this, which is on page 70 of your textbook, page 270. So determining the components for the formula method, we need, as usual, D, H, and Q, which we know from above. Remember, D is the desired dose, H is the dose on hand, and Q is the dosage unit. And we also have A, the amount to administer. So for formula method, we are going to use D over H times Q equals A. So the dose on hand the desired dose divided by the dose on hand times our dosage unit is going to be equal to the amount to administer. Alright, so let's take a look at our problem that we have. So I'm going to say that's ampicillin. I'm sorry, I don't quite know how to say that. So we're ordered ampicillin, 250 milligrams, and then we have on hand 0.5 grams. Alright, as usual, first off, we're going to check. Are they in the same units? If not, we're going to have to convert. So they are not in the same units. This is grams and that's milligrams. So we're going to have to do that first step to do the convert. Alright, so we're needing to go from milligrams to grams because we have grams on hand. And we're going to go ahead and recall that 1 gram is equal to 1,000 milligrams. And going ahead and converting for our proportion, we have D over 250 milligrams, which is what we're trying to convert from, equals, and our conversion factor, 1 gram, 1,000 milligrams. To save space, I'm going to indicate going that way with that arrow. This is an indication to that direction. It's kind of how you use that. With a cross multiplication, I'll get that D times 1,000 milligrams is equal to 1 gram times 250 milligrams. We can go ahead and cancel the milligrams, and in the same step, let's go ahead and divide by 1,000. Simplifying that out, we get, once again, the indication arrow, D equals 0.25 grams, which is our desired dose. So now we can go on to the second step, which is to find the amount to administer, which is our A value over here. So first we need to determine D, H, and Q. Let's go ahead and write those out. So what is our D value? D is the desired dose, which is 0.25 grams. We solved for that over here. Now we need H. H is the dose on hand. So what do we have on hand? Well, we have 0.5 grams. And then we need Q. Q is the dosage unit. So the dosage unit is what it's per, so this is 0.5 grams per milliliter. So per milliliter is going to be our dosage unit. So it's going to be 1 milliliter. And there we go, we have our D, H, and Q. So we can plop those into our formula. So A equals D divided by H, so it's going to be 0.25 grams divided by my H value. Once again, I got this formula from page 270. And we're multiplying that by our our dosage unit, 1 milliliter. We can put that over 1. So A is going to equal, let's see, first let's cancel the common units, the grams, and milliliters the leftover. And then we have 0.25 divided by 0.5 milliliters, which is going to end up being A equals 0.5 milliliters. Alright, so there we go. The amount to administer is 0.5 milliliters. So the formula method's kind of nice. Let's go ahead and use the formula method another time. And to recall, the formula is d over h times q equals a. So, what do we have as our order? Ordering is metformin to grams, and then we have on hand 1,000 milligrams. So as usual, we need to figure out the dosage ordered, the desired dosage. And to do that, we need to make sure that these are in the right units together. If not, we'll have to convert. So they are not. This is milligrams down here and grams up here. So first things first, we're going to go ahead and calculate the desired dosage. So first step, calculate desired D, which is our desired dosage. We started at grams and we want to go to milligrams because what we have on hand is milligrams. Alright, so to do that, we can go ahead and set up our proportions. So the desired dosage over what we have, or what we're trying to get from, which is 2 grams. And then our conversion factor, we can go ahead and use the normal one, which I'll write it on the side. It's 1 gram is 1,000 milligrams. We'll go ahead and use that in our proportion. So 1 gram, 1,000 milligrams. We'll go ahead and cross multiply to solve. Once again, you can pause this video to try solve by yourself if you want, and check back in with me. Hopefully you pause the video to try and solve this by yourself. So D equals 2,000 milligrams. So that is our desired dose. Desired dose. Okay, so we found our desired dose. The next thing we need to do is to calculate. So I'm going to go ahead and block this off here. So our first step was to calculate the desired dose or convert. Second, we're going to find the amount to administer. We'll go ahead and use our formula above, which means we need to find our desired dose, which is right over here, 2,000 milligrams. That's what we solved for in the first step. And then we need the dose on hand, which is 1,000 milligrams. And lastly, we need Q, which is our dosage unit. And the dosage unit is 1 tablet. I neglected to input the picture for this, where we get the 1 tablet, but that is going to be, if you check figure 12 to 6 on page 266 of your textbook, you will find that piece of information there. Alright, so the dosage is 1 tablet. I'll go ahead and see if that is actually, I think it's further up on my, yes. Okay, let's go back to make sure we can see this. Going all the way back to the, there we go, right here. It is per tablet, 1,000 per tablet. So that's the dosage unit we're getting for our next problem. Sorry, I should have copied that back down. But if you're printing this out, I was trying to save some ink. Okay, so that's how we got the 1 tablet. That was the unit. Let's go ahead and plug this into the formula. Once again, the one right there. So D divided by Q. Oops. 1 tablet. Times. Oh, I said that wrong. It's D divided by H. I'm sorry. Times Q, which is 1 tablet. Oh, whoa, I messed this one up. Back up. It's D divided by H. So D, which is 2,000 milligrams, the desired dose, divided by what we have on hand, which is 1,000 milligrams, times the unit there, 1 tablet over 1 is going to equal the amount administered. Alright, let's see what cancels here. Milligrams cancel out. And in fact, we can cancel all these zeros. So we're just going to be left with 2 times 1 tablet equals A. So 2 tablets. Which means the amount to administer is 2 tablets. Wow, we seem to get 2 tablets a lot. The amount to administer and there we go. And that is it for Chapter 12. Please email me if you have any questions.